Okay, lesson 1.4, classifying angles. So just a couple of things real quick to review. We talked about this array. How is array different than a line? Array only goes in one direction. When you name array, you can name it with a word. You can name it with array symbol. The thing you want to do that's in common here is that when you name array, it has to start from the same place. So all of these start with M because that's the starting point here. Now, I'm going to write this over on the side. You could say ray OP. The difference is ray OP would start at the point O and then go. So it's different than array MP, which starts back here. So it's just array. Opposite rays are arrays that have the same starting point. So these both start at the point J, but they go in opposite directions, JH, JK. Now if you notice, even though JH goes to the left, when you name it, it's still pointing to the right because you have to put the starting point on the left side. So what is an angle? An angle is formed by two rays. This technically is not an angle. We call it a straight angle, and we'll talk more about that here in a minute. But here is an angle formed by two rays. Now, it doesn't have to be two rays, and we'll see that as we go on. The point where the two rays meet, their starting point, is referred to as the vertex. The other two parts are called the sides of the angle. You can name an angle in different ways. This angle can be named just angle X, angle 3, a number that's written on the interior of the angle, or it can be named by the 3 points here, YXZ or ZXY. The thing that has to be in the middle is the point X because it's the vertex. So X, X, and X here. So when we talk about the interior of angle, we're talking about points that are inside of it. So if I'm taking this as my angle here, NMP, S and R are on the interior. Now, not Q. Q lies on the angle. The exterior would be points outside, so P and O are on the outside or exterior. So when we name an angle in terms of its measure, there are really just three types of angles. So you use what's called a protractor to measure, and you measure in degrees. Now, I'm not going to go in great detail here, but when you measure the starting side, wherever 0 is, those are the numbers you use. So here I use the interior numbers. That's a 50-degree angle. I use the 50, not the 130, because this side started on 0. So make sure when you're using a protractor, you know which set of numbers you're using when you measure. It goes all the way from 0 to 180, and that's that straight angle again, formed by two opposite rays. So what are the types of angles? Well, these are the three types: a right, acute, and an obtuse. So a right angle, we know a right angle by the box, or we know that it's 90 degrees. So they have to tell us something like that. An acute angle is one that is less than 90. So this angle is less than 90. Why? Because it's inside the box here, the interior. An obtuse angle is bigger than 90, but less than 180. Okay, so this is obtuse because this angle is bigger than the box. Okay, what is an angle bisector? It's very similar to a segment bisector. All an angle bisector is something that divides the angle into two equal parts or congruent. So 80 and 80. Another thing you'll see are the arcs here. This arc and this arc. That means those two angles are equal. Just like when we did segments. Remember when we did segments? If the segment parts were equal, they had little dashes. So with angles, they just use little arcs here. So we're going to do some quick problems here. This first one, named the vertex of angle 4. So I look for angle 4 in the picture, which is right here. So wherever the 4 is, the point that is right next to it, in this case is the point U, that is the vertex. It says name the sides of angle 3. So here's angle 3. It's between these two line segments here. So we would say the sides of the angle are XU and XW. Now technically you would want to say ray XU. So if I wrote that up here, it would look like this: ray XU and then ray XW. What's another name for angle 2? So I find angle 2 here. Now, in this case, I can't just say angle Y, and here's why. If we go back to the other slide, the only angle that was there was X, so you can name it just X. But here at Y, I have this angle, angle 2, and this angle. So I can't just say angle Y. So if I'm going to name it differently, I have to use 3 points. So I could use X, Y, U. That would be okay. So I use angle X, Y, U. Or another option is to go the other direction. U, Y, X. So I could say angle U, Y, X. And that would be okay. So what's another name for angle U, X, Y? So one thing I try to do is tell students trace. So start at U, go to X, then Y. U, X, Y. So I could just name that. I'm going to have to do a little erasing here. But if I look in there, I could just name it angle 1. Because 1 is inside of where U, X, Y was. Okay, let's go on down here. And I'm not going to do all these now. Just wanted to focus on that a little bit. It says copy the diagram shown and extend each ray, classify each angle. So they're wanting you to use a protractor, but we're not going to do that. We're going to just do some things based on what we know. So what we do know is this right here is a right angle because of the box. Now, one of the things I always tell students, don't trust pictures, trust information. So if I'm going to take, for instance, the angle BFC. So BFC, I know that's a right angle. Why? Because that has a box with it. Okay. Now, if I take angle AFB, for instance, what I know is that is an acute. How do I know it's less than 90? Well, here's how, and something you need to remember. A straight line is 180 degrees. It's called a straight angle. It's not technically an angle, but that's what we call it. So if this much right here is already 90 degrees, then all of this, and all of this together have to be 90. Well, if that's the case, then each one of them has to be less than 90 individually, which makes them acute. Okay, let's go to the next one. These are a little bit more difficult here. So what we're going to do here is we're going to use the figure, and we're going to fill in information based on what the problem says. So number 9, if LKM, so again I'm going to trace LKM, so all of this is 7x minus 5. And NKM, so just this little part inside is 3x plus 9. It says find LKM if we know that KN bisects. Now that's important because if it bisects, it goes through the middle. So here's what I know. If this is going through the middle, then this part and this part are equal. So if this was 3x plus 9, then that's 3x plus 9. Now, the reason that's so important is because I need to set up an equation. So my equation is going to be based on the information I'm given, which is 7x minus 5 has to equal 3x plus 9 plus another 3x plus 9. Because if it bisects, again, like we said, this part and this part have to be the same. So those two together have to equal what that whole thing inside was. So we work the equation out. I'm going to do that real quick here. So that's going to give me 6x. So I have 7x minus 5 equals 6x, add those, plus 18. So I'm going to subtract 6x. So if I do that, I'm going to do a little trick here, and I'm going to get rid of some stuff so I can write. It's like magic. Pretty cool. Okay, let's keep going. So I do that, and I get x minus 5 equals 18. Add 5. So I get x is 23. Now, the question, though, asks us to find LKM. So if I go back up, LKM was 7x minus 5. So what I have to do is I've got to substitute 23 in for x. So if I do that, that's 161 minus 5, which would be 156 degrees. So just to help you out, I'm going to go ahead and do number 10 too, because again, this is a little bit more complex stuff. So again, I'm going to do some magic here. I'm going to erase some stuff right here. Not really erasing, just creating space. Just go ahead and get rid of this. Okay, now I'm going to try and go back up here and use my eraser to get rid of this stuff in here, because now I'm going to go to the information in the next problem. So one thing I tell students in geometry is, as you're doing problems, a good idea is when you're using pictures to fill stuff in with pencil. That way you can erase it and change it for each problem. So right here, I'm going to put this in for NKL. So NKL is right here. So that's 7x minus 9. And JKM is x plus 3. Okay, now remember, we said at the beginning that Kn bisects LKM. So Kn's right in the middle. So what that means is, again, this would be 7x minus 9, because these two have to be the same. And if I take all three of these together, I make this straight line. Now we got through saying a minute ago, lines have to equal 180. So our equation becomes x plus 3 plus 7x minus 9 plus 7x minus 9 equals 180. So I combine these and I get 15x. It's going to be minus 15 equals 180. Add 15 to both sides. So I get 15x equals 195. And if I divide by 15, that's going to give me x is 13. Excuse me. Now, I've got to go back. It says find JKN. Now, what is JKN? So JKN, I'm going to use my highlighter here, JKN is that. So what I have to do now is I have to go back and plug in 13 to get JKN. So I have right here 13 plus 3 plus, now I'll plug 13 in right here, 7 times 13 minus 9, and that gives me that angle, JKN. So I work this out, 13 plus 3 plus 91 minus 9, so 16 and 91 would be 117. I believe. Minus 9. Sorry, not 117. 107. Minus 9, and that would be 98 degrees. So one of the hard things with geometry is figuring out what relationships to use, such as right here, to set up your equation. Then you've got algebra involved to solve. So this can be a little tricky lesson. So make sure you take your time with it. Go back and watch the video again if you need some extra help.